Picture this. You were thrown into a dingy room and told you can't leave until you have created the thinnest material known to man. Not only that, it must also be the strongest, the best thermal conductor, and as good at conducting electricity as copper. I know, it sounds hopeless. But luckily, you know something about nanotechnology. You know, really tiny devices and materials that are less than 100 nanometers in size. Of course, I don't have to tell you, a nanometer is a billionth of a meter. That's roughly the size of 10 atoms. But how do you create something that tiny? It's time to embrace your inner MacGyver. You're going to need a pencil, some Scotch tape, and a healthy dose of elbow grease. A pencil contains not lead, but graphite, which consists of sheets of carbon in a hexagonal lattice. When you write, layers of graphite slide off the tip of the pencil and stick to the paper. Usually many layers are stacked on top of each other, but once in a while you get a single layer of carbon atoms, and this is called graphene. In 2004, Andrei Geim and Konstantin Novoselov created graphene using nothing but graphite and Scotch tape. They placed a graphite flake onto the tape, folded it in two, and then cleaved the flake in half. They repeated this procedure a number of times and then studied the resulting fragments. To their astonishment, they found some of the pieces were only a single atom thick. This was particularly unexpected because it was thought a single layer of graphite would not be chemically stable, especially at room temperature. Graphene conducts electrons faster than any other substance at room temperature. This is because of the extraordinarily high quality of the graphene lattice. Scientists are yet to find a single atom out of place in graphene. Since the electrons aren't scattered by defects in the lattice, they go so fast that Einstein's relativity must be used to understand their motion. And this perfect lattice is created by the very strong yet flexible bonds between carbon atoms, making the substance bendable, but harder than diamond. Graphene is incredibly strong. If you could balance an elephant on a pencil and support the pencil on graphene, the graphene wouldn't break. Of course, the pencil would. For their discovery, Geim and Novoselov were awarded the Nobel Prize for Physics in 2010. And this is only the beginning for graphene. Scientists are hard at work exploiting its unique properties to create thin, transparent, flexible touchscreens, smaller, faster, more energy-efficient computers, tough composite materials, and more efficient solar cells. And now consider, this is only one aspect of nanotechnology. So in order to think big, you need first consider the very small.